My name's John. I'm a 15-year Aruba veteran now, which is sort of amazing that they haven't fired me in that amount of time. Today could change that. If the demo doesn't work well, that could all come to an end. But I think it's fair to say I'm fairly indoctrinated into the Aruba Kool-Aid over that time. In fact, I've probably created a lot of the Kool-Aid myself. So I do take a fairly network-centric thought process around security, and kind of my other claim to fame is I help operate the Wi-Fi and the wired network for both DEF CON and ShmooCon for about the last 4 or 5 years. And some of the techniques we use at those conferences for running a network at a HackerCon, which is going to clearly be a hostile environment, is really what I'm going to talk about today. And I'm not suggesting that an average enterprise network should be run like a HackerCon, because we actually break a lot of stuff on those networks because we have things locked down so much. But there's a happy medium between that and what I see at an awful lot of enterprise customers. And you know, I have the chance to talk to a lot of different types of customers. I do a lot of federal government, living out in DC. I see K through 12 school districts. I see Fortune 500 companies. There are things I see in common with a lot of those places in terms of how they react to security and how they react to things like pen testers coming in and dealing with that environment. So if I can switch this over, let's see how this goes. So I want to start with just a quick demo, and we'll cross our fingers for live demos. So far, so good on the rest of them today. This is not an earth-shattering demo. It's not going to be surprising, the things that we're able to do on this. I have a Windows laptop here. It's joined to a domain. The domain controller is running right here on this little box, and there's a router running on there too. And everything is connected here into just a silly dumb switch. So nothing fancy happening in the network there. Bad guy gets on your network. And that bad guy could be a pen tester that was hired by the security team to try to break into the network, or it could be a legitimate bad guy physically connected to the network, or with just software that's connected to one of your employees' device, or that's running on one of your employees' devices. Typical first thing they're going to do is come in and scan the network. And so looking for other devices that are out there, just doing basic reconnaissance. And so I'm running just a graphical front end to end map here, just because it looks nicer from a demo standpoint. This is noisy. If you had an IDS, or you're going to hear about Introspect coming in the next session, sitting on that network and monitoring that, this is something you would see. It's not particularly stealthy here. We can make it more stealthy, but it takes longer to return results at that point. A lot of people don't look at the access network, though. They kind of say, well, I'm going to wrap my protection around my data center assets or my cloud assets. What comes out of the access network, there could be choke points where we're looking at things in the middle there, but within the access network itself, things are fairly wide open in an awful lot of customer environments. So what we see at return back here, a few stations that are on the network. This guy right here is 10.4, and you can see right down here, just looking at the results there, we didn't go through kind of fancy OS fingerprinting or anything like that, but it looks pretty clear from the ports that are sitting there. That's a domain joined Windows PC. It's port 135, port 139, and 445. So not only is it domain joined, it's got file sharing turned on, which is fairly common again on domain connected networks. And Windows is good at saying, I'm on a domain connected network versus I'm on a public network, and turning those services on and off. But on a domain connected network, you're gonna see things like that. So there's somebody that I might like to target. So I've got a list of resources and assets that are on this local network now. The next thing I really want is credentials. So I'm going to run just responder here. Oops, I need a capital I. And again, this is a fairly basic attack that a pen test firm would try to carry out. Over on my Windows system here, you're going to have to trust me on this. I'm just going to open up Windows File Explorer, hit / server. And I'm looking for, I'm trying to mount a shared network drive. And this guy's sitting here and basically going to poison that response. It's going to come back, and there's a credential. So what basically happened is this guy says, I'm looking for server. The attacker is sitting here saying, I'm server. Give me your credentials to authenticate to me. And this guy happily handed over his hash for his domain password. If we now go in and we've got that captured there. So if I look at this SMB There's the password hash that we captured at that point. And now I can run our old friend, John the Ripper, to crack that password. And not surprisingly, I didn't set a very complex password here. I didn't want to bring a GPU rig out and run Hashcat and things like that. But here's my password. It's let me in. And so now I have a valid user on the domain. There's the domain SFD. There's my username. And there's my password. And I think it makes the point, the next step is to start running things like psexec, and we're going to run processes on this device here. We're going to try to, get some kind of, if I can get Meterpreter running here, I can try to dump the password database on this device, and chances are really good there's going to be an administrator who's logged into the system at one point or another, and now I've got administrator credentials. And so typical story from a pen test firm is they can come in, and from the point at which they get physical access to the network, it's about 15 minutes and they have domain admin rights. That's over and over and over again. People talk about how easy it is to do that sort of thing. And this is the basic step for doing that sort of thing. Again, if you've got security between the access network and the rest of the network, say between access and data center, for example, or between access and internet, you didn't see any of this stuff. There's no way to stop these sorts of things because more or less we say, well, the network is the network. And so what should we be doing about that? What's going to be the response to when the pen test firm comes back and issues their report? And you're going to get to see the true power of my PowerPoint skills here. Just to get that text curved on the top took me way longer than it really should have, but it's not my strength here. What I think we see a lot is this siloed environment within companies, and even if you get down into IT departments. Things are siloed between security and network and desktop and systems and that sort of thing. And so the response from to a pen test like I just did, such as it is for the security guys to go after the systems guys and say, hey, link local domain or name resolution should be shut off. Push a group policy out to the Windows systems to say turn that off. And that's an arms race, because the next thing that the pen tester does is, well, I can control DNS on the local network, and I can do that 50 different ways. And so it's a race there. What I find in an awful lot of companies is at no point does the security team approach the network team and say, what can we do from the network perspective to stop this sort of thing from taking place? There's sort of an attitude of, the network is the network. It's a pipe. And if the pipe carries good traffic or the pipe carries bad traffic, we really can't do anything about that. There's kind of a resignation there, to the point that I actually find hostility in a lot of places between security and networks. Like, those people do not want to talk to each other whatsoever. And I think we can do a lot to make things better if we can get rid of that idea. So I'm not going to try to sell you a product today. I'm going to try to sell you an idea and an approach to things which says these silos need to not be silos anymore. And I almost put in a picture of, like, you can get grain silos that have links between them, but I thought that was too ambitious for my PowerPoint abilities. The other thing we find a lot is just this idea of fortress mentality, and this can mean a few different things. This is the classic kind of hard perimeter, soft and chewy on the inside thing, and the network, the access layer network, seems to be the softest and chewiest of all in there. It's the idea that me being connected to a particular network segment confers some type of access rights into the resources that I can get or the things that I can do. And I think people are getting that through their minds, that has to go away, because as soon as a bad guy gets his malware running on this corporate connected device, you're on the inside at that point. And so there's no perimeter there anymore. So I think you're starting to hear things like zero trust networking out there. And that's, if you follow kind of the Gartner hype cycle, I think zero trust is at the peak of inflated expectations at this point, judging from what I saw at RSA last year. Zero trust is great. It's a good idea. I heard it earlier today. Why don't we focus on, everything should be TLS 1.3? Perfect, it should be, except for all the stuff that doesn't run TLS and is not going to run TLS, and that, the clock that's hanging on the wall back there that's connected into the network, that sort of thing. So zero trust networking and the mindset that goes with it is a really good start. I think it's insufficient. I think we can do more than that, and especially as we start looking at things like IoT. The second aspect where this fortress mentality comes up is literally the four walls of the building, or five if you're the Pentagon. But it's the idea that nobody's going to get into the building, and so the wired network in particular is something that we should be able to trust. It's still really, really common to be able to walk into a conference room in a building somewhere, connect into a network, and you've got access as an employee would. Or to find a printer and to unplug the printer port. Pen testers do this all the time. Find a printer, unplug it, plug into the printer port with a laptop, clone the MAC address of the printer, and you're on the network at that point. And usually not with very many restrictions, depending on how people have done things. Mm-hmm. So there's a real attitude that physical security makes this not a problem. And you've probably seen lots of social engineering attempts where people get into buildings pretty easily. Wear a white-colored badge, flipped around backwards, be making a phone call and follow some people in coming after lunch. Nobody challenges you for that. It's easy to get into buildings. And here we are in 2018. We've had port-based authentication for what, at least 10 years, probably longer than that. We still find an awful lot of places people don't use that. And I get it. It's difficult to turn on port-based authentication. .1x has all kinds of interoperability challenges and needs to poke holes in things like that. And that's one of the things that we've worked on with kind of the previous demo, the switching and the ClearPass, is there are graduated steps you can take between wide open access and full port-based authentication. We can do things like device fingerprinting. We can take our best guess at what that device is and try to enforce access rights. So fortress mentality is really something we still need to get rid of. On the other hand, that doesn't mean you treat your access network in your enterprise like it's the dirty internet. There's no reason to go to that step necessarily, because people will take that mindset and say, well, I might as well not do authentication whatsoever. Why worry about stuff like WPA3? Why worry about things like port-based authentication? If I have this zero trust networking mindset, I'll just drop things on the network and anybody can come in and use my corporate network as a public hotspot because we have zero trust networking. I don't think we're there yet. I don't think we're going to get there. And the demo I just gave kind of shows one of the reasons why, because if you're trying to target that environment, that's a target-rich environment to get onto that local access network. So the idea that I talk about a lot is, I use the phrase adaptive trust, and it's building on top of, I think, starting with zero trust. And zero trust really is zero trust initially, but we have to build up some amount of trust. Zero trust networking really means I'm shifting the trust from the network to the device. And so now it becomes even more important to protect the device. The idea of adaptive trust is essentially, we've gotten good in the data center and in the cloud at building perimeters around the data that we care about and getting down into micro-segmentation and micro-perimeters and that sort of thing. The idea of adaptive trust is to take that same idea, bring it to the users, bring it to and say every single user is going to have a firewall wrapped around them, because we don't trust users talking to other users, and we don't trust users talking to devices on the local network. And as you get into things like zero trust and buying into some of the hype that goes along with that, it turns out we're really talking about segmentation. We're really talking about zones and building trust zones within the organization and saying, like the picture shows here, I've got these two consultants and they're both in the same zone. That's ignoring what happens within the zone. I don't necessarily trust two employees talking directly to each other on a network. And so this becomes, kind of the other side of data center, microsegmentation is microsegmentation within the access layer network. So I'll give you another demo here. I'm going to go back to my Kali workstation here, which probably locked the screen. There we go, of course. And I'm going to move the network ports here. I'm going to just shift over to a little Aruba controller that I brought out with me. And we'll just bring up the command line. Tim was nice enough to show you the graphical interface. I'm old school that way. I like the command line. So these users are all connected to wired ports now. And you saw in the last demo, we have lots and lots of ways of differentiating between Windows laptop and uplink and that sort of thing. For the purpose of this demo, I just set up a default rule that says everybody in there gets this role called SFD wired user. And I can look at a real simple firewall policy that says what can SFD wired user actually do. There's a list of ACLs, we consolidate them together, and it says basically, anybody can do DHCP. Now in reality, we would lock that down to a particular DHCP server. This is the gateway. Anybody can talk to the gateway. Anybody can talk SIP. So I've allowed voice over IP to flow through this network. But if any user on this segment tries to talk to the rest of that particular segment, deny that traffic. So don't allow traffic to flow between devices on the network unless I poke specific holes in here to allow it. That's kind of what we do at DEF CON. We don't put holes in it though. It's deny everything. We don't even let ARP through. So you literally are tunneled out to the internet, and that's all you can do on that network. And it's made life so much better from the days I used to do the Black Hat Wi-Fi network, and people came out of the training and they would just attack each other all conference long, and we'd have to track them down on the floor and say, can you just stop? Wait till you get home. And then the last rule just says, if you're not talking to this local network, permit your traffic to go through. So that's kind of where we are. So what I'm going to do, first of all, go back to Kali here, and I'm just going to run a port scan again. And it's going to sit there in the background and do its thing. And if we go back to kind of the controller here and look at what's happening on the firewall, we're seeing some hits. So the new hits column there under the deny rule is incrementing, and it's showing new hits from the last one. So there's stuff going on there. Basically, we're saying a lot of the scanning that Nmap is trying to do here is going to be blocked. Now, certain amounts will be permitted, so you're actually going to see the devices will show up. So I've discovered all the devices, and that's because ARP was allowed to go through here. We have the option of shutting that off, but it breaks a lot of things that we might want to allow. But what you'll notice is on this one right here, this is my Windows client again. It knows it's there. It sees its MAC address, it sees its IP address, but there's no services open. The firewall didn't allow Nmap to figure out anything about that client. And likewise, if I go back here and run Responder again, same thing here. I'm going to go back to my client. I'm going to open up Windows File Explorer and hit server. It's going to search for that. And what you'll see is the request is getting through. So that's a multicast that goes out on the wire. And this guy thinks he's poisoning that response. So he's sending traffic back out. That traffic that he's sending back out as an attacker is getting dropped by the firewall. So it's not going to get through there. So that attack fails. There's other ways I can escalate those attacks, but in general, I have very tight-grained control because every single user that's coming through that infrastructure, whether it's wired or wireless or VPN, we don't really care how they get into that system, has that firewall policy wrapped around them. But what I can do here that is difficult with a firewall, remember I left voice over IP open. And I'm just going to start a packet capture here on the local network and go back to my Windows client here. There's a little SIP client running on here. I didn't think it was worthwhile bringing out full Microsoft Call Manager and that sort of thing. So it's just a point-to-point SIP client. But I'm going to call this guy. So I'm making a SIP call. There's my call popped up, and hopefully audio shut off so we don't get the feedback. But my voice over IP connection is connected there. What you'll see if we go back to Wireshark here, is something that a switch can't really do. Because people will say, well, I could just put ACLs in the switch and do a lot of what you're trying to do there. This is kind of where that breaks. So here, if we look at the SIP session that's being set up, look down here, the port number is UDP 5060, and that happens to correspond exactly to the firewall rule that I put into the controller to say, permit port 5060 to go through. But after we have the call proceeding here, it's ringing, we pick it up, and now at this point, the actual RTP session starts up. That's on an entirely different port. That's port 5094. Only through stateful monitoring of a SIP control channel could I allow that to happen. Otherwise, I would have had to open up an entire range of port numbers and that's just more attack surface for an attacker to go after. So bringing firewall technology down into the access layer network is what allowed us to kind of permit this sort of thing to happen, but stop the attacker tools from functioning. So that's the big idea. And I don't care if you use my firewall. Obviously, it's well integrated with the network infrastructure. A lot of people are passionate about their particular firewall vendor. That's fine. Bring that in as well. But the idea is each user's traffic should flow through that firewall session, even at the layer of the access network, because that's where we can stop a lot of badness from from happening in the first place. So that's the big idea. Essentially, again, I think it's an approach that we don't take. We tend to overlook the network, and I'm not sure why. I'm not sure what the answer to that is. I'm hoping, that to maybe start a discussion that, that gets us closer to that. But I think we have to cure this idea of hostility between networks and security if we're going to get, try to solve some of these problems.
How do you see this being used in practical cases inside networks that have to maybe use this as an alternative to, I don't know the best way to put this, maybe standard segmentation practices between something like a PCI cardholder data environment and other areas?
Or NAC adoption?
Yeah.
Yeah, I think this approach is taking segmentation, and it's still doing exactly what segmentation does, but it takes it down to the level of the individual user, the individual device, as opposed to zones. I think zones are not secure enough. They're a good idea, and saying this is the dirty zone over here and here's the PCI zone, that's fine, but as soon as I pop a box in the PCI zone, now I more or less am free to laterally spread around inside that particular zone. So if I get one card reader, at a Walmart, now I can get all the card readers at Walmart because there's no separation between those. This is just saying segmentation doesn't end at a zone, it actually ends at the individual device, which again is kind of getting into that concept of the zero trust networking approach of saying the thing that we trust is that TLS session between the client and the server where it's pulling its data down. So I think it's just making that more granular.
Now, even to that point a little more with the granularity there, some of the new privacy regulations coming out are requiring a lot of similar concepts with that, but you don't necessarily have defined, most organizations I'd say don't have defined zones of this zone has NPI and this doesn't. It's going to be based off of systems and use cases within the organization. Do you see any possible benefits of something along this line? I guess benefiting that use case, especially with how much people are trying to start spending in mitigating the risks associated with those privacy regulations? I
think so, because a lot of what that's forcing organizations to do is more monitoring and different types of monitoring. And it ends up being very expensive to monitor the entire network in the same way when that might be the network that has all of the Wi-Fi clocks connected to it, for example. I don't care about those, and so why waste the monitoring? What I can do in a device like this is say, well, this is the privacy sensitive stuff. If I'm going to dump social security numbers, they're going to come from this. That's where I need to apply DLP. That's where I need to apply, UEBA that we're going to see in the next demo and that kind of thing. While I can say, yeah, we still want security monitoring over here for certain things, but I don't need a DLP sensor attached to my clock subnet or my clock. So the ability to say, not just firewall enforcement, but actually change the forwarding path of the data is something that the controller can do to say, this user is suspicious, there's an elevated risk score, or this user is coming from a PII segment in the network. Their traffic doesn't go to the default gateway, it goes to this other default gateway up here, and we apply a whole security stack within that. So I think it helps you just not overinvest in monitoring, if that makes sense.